Welcome to this video where we will be talking further about ionic bonding. So as we saw from the previous video, we have the idea that ionic bonds are involved with metals like sodium and non-metals like chlorine. When it's a neutrally charged, it's called chloride. Go and have a look at that video, part 1, if this is not making sense to you right now. Okay, so let's get further and further into this idea of ionic bonding. So each atom, now I'm not specifically talking about sodium or chlorine here, I'm just talking about any particular atom, will look something like this if you had to really look at it on a very, very, very deep and diving in kind of magnifying the atom itself. An atom is made up of subatomic particles. We know this from prior modules, of protons and neutrons. These guys are found in the center of the atom over here. But what's really important for this lesson is the idea that the atom has electrons that can fill certain spaces. Now the spaces are available in certain sort of shells, and they're otherwise known as energy levels. Okay, or shells. So there's the first energy level, that one over there. Then there's the second one over here. That's got 8 available spots. The first energy level has 2 spots, and then the third one also has 8 spots. So the second and third one have, sorry, this is energy levels, and these got 8, and these ones have 2, and the third one energy level has 8 as well. Okay, and at international GCSE we only have to do 3 levels. Okay, so let's not worry about any other levels. There are other levels that exist, but for now let's just work with 3. Okay, so now what happens if I can just get rid of this for now? So I'm just going to highlight this and delete it, and then what I'm going to do is I'm going to take some pre-prepared sort of electron configuration diagrams, if you will, and I'm going to put them underneath sodium, and I'm going to put this other one under chlorine. Okay, and we're going to actually see, when I spoke about in the previous video, when I spoke about, oh, we've lost a little space, let's put him back, there you go, happy chappy. In the previous video, I spoke about how chlorine and sodium become charged, and this is the reason why they are attracted to each other. And in this video, I want to talk about how does that actually work in terms of the electrons. Okay, so I've got sodium over here. From the periodic table, this atomic number over here tells me that sodium has 11 electrons, and it also has 11 protons. Okay, now the protons are sitting here in the nucleus. I'm not really concerned about the protons right now. Just want to talk about the electrons. Okay, let's go and talk about the electrons. So if we had to fill in the electrons for sodium, let's get sodium just sort of in the middle there. This is where the protons and neutrons would be, but let's just put sodium there for now. Okay, 11 electrons. This is how we do it. The electrons fill up from the closest available spaces, if you will, or the first energy level, and then they move outwards, and you have a potential of 11 electrons to fill here. So watch me do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have the 11th electron in the third energy level. Okay, now I just want to tell you that atoms like to have full energy levels. Okay, right now sodium has one electron filling a space here, but it's got all of these empty spaces. It's a very unhappy element right now. Okay, let's go and do chlorine and come back to how sodium is actually going to get a full energy shell, and I think some of you can already predict what's going to happen. Okay, chlorine. Let's do chlorine quickly. We got chlorine. We've got 17 available electrons, so we've got 17 electrons and 17 protons. Beautiful. Okay, so let's fill up those electrons. We've got 17 to choose from. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Again, we don't have a full energy level. We don't have a full shell. Some teachers might say that this shell is not complete, and atoms really are unhappy when they have incomplete shells. So what's going to happen in this situation right here is sodium is going to take this element, I was about to say element there. It's going to take this electron here, and it's going to give it to chlorine. What's going to end up happening now is if we had to redraw these pictures, we've then got now sodium that's super happy. It's got these two over here, and then it's got a complete second shell. 2, 3, 4, 5, 6, 7, 8. Sorry, this is going to make much more sense. Let's get that pen over there. Okay, and you can actually go and draw this while watching this video. It will be super helpful for you. Okay, so that now is a sodium atom that has lost an electron. Remember, it's lost an electron. So if we think about the total amount of electrons in this new sodium atom, we now have 10, right? Electrons. We had 11 in the previous diagram, now we have 10. How many protons? Well, protons have stayed the same, right? Protons. Remember, protons are positively charged, P for positive, and electrons are negatively charged. So if you did a quick little bit of math here, the overall charge of the sodium atom is going to be a positive 1 charge because it's got 1 extra proton compared to its electrons. So what about chlorine? Well, chlorine's gained an electron. It's gained an electron. We can actually just simply copy this diagram. Let's just copy it a little bit better than that, Stephen. Come on. Okay, and here it is. That's also quite a bad paste. Let's put it down here. Okay, that's better. Here we go. Now what we can do is we can just take this and just for diagram purposes, come on computer, stop freaking out. Okay, there we go. It listened to me. Okay, we take that and put a little green thing in, okay, because this is not happy chlorine atom. It's taken that one from the sodium. So if you had to count the electrons, there would be 18, right? 18 electrons. How many protons? 1 less, 17 protons. So the overall charge of this of the sodium's +1 and the chlorine is -1. Okay, and can you see that when this sodium atom loses that electron, it becomes a +1 charge, the whole atom itself is positively charged. The chlorine's gained that electron, the whole atom itself, remember these things are called ions. Okay, these ions now have this charge and they are attracted to each other, and this concept of the losing of the electrons and the gaining of the electrons in terms of the structure and where these electrons are sitting, this is the reason why these atoms become positively and negatively charged, and that is the reason why they are attracted to each other, and that's why they form this bond. It's called an ionic bond. I hope it's been helpful. Thanks very much for listening, and coming up is part 3 of ionic bonding.